Hello everyone, in this video we're going to start to exploring the two type of arrows, and so to understand those arrows it also allow you to do better down the road if you want to become a data scientist, and you have to know what is type 1 and type 2 arrow. And so also by learning the different arrows you will be able to know as a statistician when we do a hypothesis testing what are we really trying to control and what arrow we cannot tolerate. Okay. So it is possible to make an incorrect decision regarding the null hypothesis. So as illustrated in the table below, either the null hypothesis is true or it is false. And we have two possible choices concerning the null hypothesis. We either reject HO or fail to reject HO. So let's walk through this table together. So for each row, you can see we are using reject HO, fail to reject HO as the action we are taking, okay? And so for the vertical columns, each column, they are labeled as the fact. So the first column is labeled as HO is true, and the second column is HO is false. So I know some students are going to ask, hey, Dr. J, why we don't talk about H1? Remember, in the previous video, we emphasized that for the hypothesis testing, we mainly focus on are we able to reject HO? Because if that's the case, we will take H1, right? So therefore, we mainly focus on HO. Now, after you know what we are labeling, so basically for each row, the row label is representing the decision we are making. And each column are labeled using the fact. What is the truth about HO? The fact is, sometimes we don't really know the truth, right? So that's the tricky part, and also it's a very hard understanding part is we actually don't know the truth about HO. Okay. Anyway, so after you know the labels, let's look at arrows. So first, the type 1 arrow. So for type 1 arrow, basically, if HO is actually the truth, we take the wrong action, say, hey, it's false. We're going to reject it. And then for so that's my type 1 arrow. For the type 2 arrow, it is opposite. So basically, HO is actually false, and we end up not rejecting it, but we should reject it. Okay. So then the horizontal, for the rest of the diagonals, so they are not arrows, so they are actually making a right decision. So for instance, as this one I'm calling out here is since HO is false, the right decision is to reject it. So therefore, it's a correct decision. So for this cell, it's saying, hey, HO is true, and we didn't reject it. Okay. So therefore, these are the 4 arrows. So I'll give you another analogy. So let's see, our students are in the business world, right? We're just talking about the variety of the product we tried, organic food Walmart tried to introduce, and they thought that's gonna increasing the revenues. So let's say the HO is that given the organic food, increasing the organic food actually had no impact on the sales, because remember in the last video we talked about HO and H alternative. So the HO always about no effect, status quo, no impact, right? So therefore our HO in that scenario will be, hey, the Walmart by introducing more organic food, it will have no impact on the revenue. Okay, so if we are making type 1 arrow, is that the truth it is, when we look at the fact is if we adding more organic variety food, we are now seeing more revenue. However, after collecting data, we do a hypothesis testing, somehow we end up reject. So we are rejecting a truth, so we are making mistakes. So you can think about, if we do end up rejecting, that means we false leading the decision maker thinking, hey, adding more variety goods, organic goods to the Walmart, they will increase in revenue. Then they taking action, they end up lose the money, right? So that's an arrow. So for the other situation, so which is HO is actually false. So that's the basically increasing the organic food variety, we will see Walmart increasing the revenue. That is the fact. However, after we collect the data to do this hypothesis testing, we fail to reject the original hypothesis, which is no in fact. So then we miss the opportunity to increase in the revenue because we fail to reject HO, right? So those are both causing financial consequences to the business, negative financial consequences, right? The type 1 arrow in that scenario causing business investing in the area they're not supposed to be. And the type 2 arrow might causing the business to missing the business opportunity. Okay, so both are creating the arrow. Now, as a statistician, and we also want to understanding like how we are able to control. Okay, so before we move on to that, we also want to call it out. So the type 1 arrow, we also call it false positive. Okay, why is that? Think about HO is we assuming there's no effect, no status quo. We should not change. And so if we reject HO, that means we are going to take action. We are going to think H1 is right. So therefore we call it false positive. We falsely thinking H1 is right. Okay. And the type 2 arrow is opposite. We call it false negative. Basically it's saying, hey, actually the H1 is not working. And so please don't take any actions. So therefore it's a false negative, represent negatively not rejecting HO or falsely not accepting H1. Okay, so in their case, again, incorrect decision was made, and we can see the consequences. Okay, here are more further diving to the consequences about type 1, type 2 arrow. Here we are not really calling out which arrow are more severe. And then, like I said, when I use the Walmart as a decision, as example, you can see that maybe with the money to take initiative is a worse outcome than missing a business opportunity. So if that's the case, your type 1 arrow is worse than the type 2 arrow, right? But if you think missed business opportunity is worse than taking a wrong investment decision, and then you're thinking the type 2 arrow is more severe than the type 1 arrow. But most of the time in the hypothesis testing, we actually want to control that type 1 arrow because we believe type 1 arrow creating more harms. If you think about the situation we're just talking about, right? The type 1 arrow, due to we wrongfully reject HO. Now we told Walmart, hey, just put a bunch of money, adding more variety of organic food, and then they end up not able to see that revenue increase. So we end up like losing the profit, right? So for the other one, the type 2, we just talked about for that example, we just didn't reject HO, so we're missing a business opportunity. Maybe we should add in the more variety goods to the Walmart to increase revenue. We just miss it, but we are not have we just missed the opportunity. That means we can't increase in the profitability. Now we just end up make the same profit. So if you think about this too, you were like, yeah, the type 1 arrow is more worse than the type 2 arrow, right? So here I'm showing you a few more examples here to make you to thinking about, hey, what is the consequence of type 1, type 2 arrow? And so how we balancing which arrow is more, must be the one we need to control, okay? So type 1 arrow is convincing, when we look at the civil law, the previous video talked about, so HO is we assume the person is innocent. And H alternative and our H1 is we assume the person is guilty, right? So HO is the person is not guilty. H alternative, the person is guilty, right? So type 1 arrow will be convincing an innocent defendant, so the costs are borne by the defendant. Okay, you can think about type 2 arrow is that we fail to reject a guilty defendant, so the costs are borne by the society if the guilty person returns to the street. So now the question is, I want to ask you to think about, do you think the type 1 arrow is more severe than the type 2 arrow? Or type 2 arrow more severe than the type 1 arrow? Okay, so this is really an important debate in the legal space, right? First of all, think about if this crime is a criminal law can end into death penalty. Okay, and then the question is, do you feel we send an innocent person to a death penalty? It has a worse outcome, or we send a guilty person go on a street is a worse outcome. Some people were thinking we are care about human rights. We should care about people's life. So we prefer to control type 1 arrow because we really don't want the innocent people be sent to the jail or even sent to the death penalty if they didn't do anything harm, right? And then the other part of people might think, oh, if we let guilty people go on the street, they're going to kill more people, right? And so there's a really interesting debate in the world. So one thing I want to call out. So in China, like I said, we flipped HONH alternative compared to US law. So that means what we are seeing here, the cost, the type 1 arrow here is type 2 in China, and type 2 arrow here is type 1 arrow in China. Okay, so later when we look at our alpha and the beta, we're going to dive in further about, hey, why we need to control type 1 arrow and how we control type 2 arrow. But here, I just want to let you really think about the consequences of type 1, type 2 arrow and think about why we need to control them, right? Okay, so next we're going to look at is, as I said, how we control it. In order to control the type 1 and type 2 arrow, we need to think about the probability of making those arrows, right? So therefore, here are the definition. We're introducing alpha and the beta. So the alpha is the one we see that very, very often in any fields. And down the road, next couple of weeks, we're going to look at this linear regression model. We're going to do the hypothesis testing for that regression model as well. We focus on alpha. Okay, so alpha basically is the probability of a type 1 arrow. Basically, the probability of the rejecting a true non-hypothesis, we use alpha to denote it. We also call this as the level of significance. Again, there's not too much explanation here, except alpha representing the probability of make type 1 arrow. Okay, and then you need to remember the jargon here. So for the statistic jargon, the alpha we call level of significance. Okay, so for the type 2 arrow, the probability we're making the type 2 arrow means not rejecting the false hypothesis. We use beta to denote it. Again, we know the existence of beta, but down the road, as you work on more and more and more hypothesis testing, you will see alpha more. Because the next slide, I will talk about how we are able to control the beta. Okay, before we move on that, I want to talk about one example because that's related to your homework assignment. Okay, think about, so the probability of the type 1 arrow is denoted as alpha. So let's say alpha equal to 0.01. Okay, 0.01. So let's look at what does this 0.01 actually means. Alpha equal to 0.01. Let's say we run 1,000 experiments. Okay, we run 1,000 experiments. So that means that probability alpha equal to 0.01 is 0.01 times 1,000. That will give you 100, right? So that means among those 1,000 experiments, we are expecting there is 100 times we are making type 1 arrow. Okay, so let's say if alpha equal to 0.05. Okay, so that means around that 1,000 experiment, we are expecting 500 times we're making type 1 arrow. So you can see as alpha increasing, the tolerance for us to making type 1 arrow become larger and larger, right? So we'll become more tolerant as alpha increasing. As alpha decreasing, we become less tolerant to type 1 arrow. So let you think about, do you think the larger the alpha, the better, or the smaller alpha, the better? Yes. So in order to do a right decision and the right and the sound decision, we try to make alpha very small, okay? Very small. You can imagine if alpha equal to 0.9, so 0.9, 90%. So that means we will tolerant, if we do 1,012, there is 900 times we make it type 1 arrow. So then why you are doing this hypothesis testing, right? So therefore, in the next couple of slides, we're going to talk about the common value we are using for alpha, that we are using that to control the type 1 arrow, okay? The goal here, the alpha should be small. Now let's spend some more time on beta. Like I said, the beta, we actually give a beta a different name. Beta is the power of a test. So the power of the test is the probability that a false hypothesis will be rejected. So power equal to 1 minus beta, and it is a complement of the type 2 arrow. So as we are reducing the beta, that will increasing our power, usually accomplished by increasing the sample size. So the larger the sample size leads to increase the power, which is why clinical trial often involve thousands of people. Okay, so that the reason we're introducing the power is that when we do any hypothesis testing, we really more focusing on the alpha instead of beta. And in order to know our test, focus on the alpha is very strong, can endure any further tests, we want to control the power. So the only way you can control the power is try to increasing the sample size. Okay, increasing sample size. That's why if you go to the real world, if you work with a leader who know the statistic, they're gonna always ask you, hey, what is your sample size? If you said my sample size is 20, they're like, okay, through everything you say, just directional suggestion. I don't think any of their statistic tests is powerful enough, because we do want powerful tests. So the rule of thumb is we try to get at least 50 observations, okay, 50 trials. And of course, in the clinical trial where the negative consequences is even worse, like for instance, you are experimenting a drug, and then the negative outcome is you can kill the person. So you'd better getting a really large sample size to do the test, because you don't want to only rely on 20, 30 patients or even 50 patients. It's too small to figure out if the drug will be able to benefit the person or actually going to kill their patient. Okay, so keep in mind, we love larger sample size when we do the hypothesis testing. Now, let's look at the relationship between alpha and the beta. So both a small alpha and a small beta are desirable. Like I said, we want to control both the probability making type 1 and type 2 error. And however, if we have a given fixed sample size, given we only use that one test, you need to know there is a trade-off between alpha and a beta. Okay, so basically, as you do the same business question, try to test the same business decision idea, you are facing this dilemma: is as you decreasing the alpha, you will increasing the beta. So basically, you decreasing the probability to make type 1 error, you will increasing the probability to make type 2 error. Okay, so the larger critical value needed to reduce alpha risk make it harder to reject HO, therefore increasing the beta risk. So both alpha and beta can be reduced simultaneously only by increasing the sample size, increasing the power of the test. Okay, so I'll try to help you understand here a little bit why increasing the alpha, and then you will decreasing the alpha, you will increasing the beta. Okay, so I want to use a very common example here, as we have AI developed. I don't know how many classes you are taking are using some kind of AI protocol systems. And then so basically, let me find my pen here. Okay, so the AI system. So let's see a professor using some of the AI protocol system. So the main goal for the AI protocol system is they can alerting, like they tagging the videos, try to see, hey, if the student are cheating or not. Okay, as you think about how you are set up the HO alternative, as an educator, I always assume my student have never cheated. So no cheating gonna be my my HO, and the H alternative is the student are cheating. Okay, so I can use T, no cheating, to represent the no cheating and cheating as my alternative. Okay, so now let's build up that type 1 and type 2 error, right? Okay, so again, my HO should be no cheating, and H alternative is cheating. Okay, and then so we have this AI alert. So this AI will make decision to look at your movement, etc., to determine, hey, if the student cheating or not. So the AI gonna say, hey, you know what? I'm gonna reject no cheating. So the AI will determine, look, this is student are cheating, and then AI will decide this is no cheating. Okay, as you can see, this is gonna be my type 1 error. Basically, the student actually didn't cheat, and then the AI decide, hey, this student are cheating. And then this is gonna be my type 2 error. So basically the student are cheating, and the AI decide, you know what? I don't think they are cheating. Okay, so the probability to make the type 1 error is alpha, right? That's what we decided. And the statistician decided. And then the type 2 errors probably is beta. So let's think about that trade-off, right? So let's see, for some reason, some professor said, I wanna make sure the system is sensitive enough, can help me to catch all the cheaters. So therefore, what they did is they ramp up the sensitivity for the AI to detecting cheating. Okay, so in that sense, we kind of trying to reduce the value of the beta, reduce the probability of the AI said no cheating, but the student actually cheating. Okay, we are reducing that sensitivity. Oh, no, so we decrease the sensitivity, therefore we are reducing the beta. Now, given that scenario, think about alpha, right? Now the AI is even you just look around, they're like, hey, the student cheating because the professor resolve that sensitivity, allow the system to reducing the value of the beta, but because that the system becomes so sensitive that even you just touch somewhere else, they were thinking you are cheating, right? So therefore, we are end up increasing the value of alpha. We will end up a lot of students being considered cheating, but they are actually not. Maybe they just look at the windows, there is a bird flying around, but now the system says, hey, this student is cheating. Okay, so you can see as we reducing the beta, we are increasing our alpha. Okay, so we have the same similar situation as well, right? So let's using the Walmart that is as example, right? The HO is Walmart adding organic food has no impact on sale, and the HR1 will be the one going to be working, right? So adding organic food will increase sale. Okay, so therefore we can say here is positive has no impact. Okay, impact, and this is increase impact. Okay, increase impact and no impact. Okay, so let's build out that table again. First of all, the truth can be there actually no impact. The alternative will be it does have impact. The increasing impact, right? Increasing sales. And then so what we're gonna make a decision. So let's see, we have a statistician who are run some kind of tests. And then so the first of all, they might reject no impact to determine, hey, you know what, we do have impact. But the statistician can run the test, found, hey, you know what, there's no impact. So therefore, this is going to be my type 1 error. Basically, the fact is there's no impact. Now we told statistician based on the hypothesis testing, she conclude, hey, there is impact. So this is going to be my type 1 error. And my type 2 error will be down here. Basically, the thing actually adding organic food will have positive impact on the sale, but the statistician said there's no impact. Okay, so this type 1, type 2 error, and so the probability to make type 1 error is alpha, the probability to make type 2 error is beta. Okay, now let's see the following scenario. Because the statistician realized that the type 1 error causing more harm to the business, as I mentioned, you basically tell the business to invest a start new venture. So you're generating the cost, adding more organic food, but actually it doesn't work. Now you end up tanking the profitability of the company, right? So they are thinking, you know what, the alpha should be really small. We need to control that. So their goal is try to reducing the alpha so that they are not end up losing the money, right? Losing the profitability. So as they are doing that, and they also will increasing the probability missing the business opportunity. So they are so careful that to make sure they so careful, but they might also miss the opportunity that they are actually going to be able to make more money if they add in organic food, right? So the probability of losing the business opportunity increase as they try to reducing the potential of the actually negative impact on the profitability. Okay, so this is the second example to help you understand, you know what, alpha beta has a trade-off. Okay, so the only way we can reducing both of them, alpha and the beta, is trying to increasing my sample size as we try to do this hypothesis testing. Okay, so hopefully this example help you to understand the type 1, type 2 error, and the probability of the making type 1 error alpha, the probability of the make type 2 error beta. Okay, so the level of the significant alpha actually is not calculated using a formula, and instead we choose a value based on our willingness to risk making a type 1 error. That's what I said. So for some reason, I personally cannot explain perfectly because it's whoever created, but the fact is the type 1 error is the one we consider want to control, sincerely control. And so that's how we are determining those numbers 0.01, 0.05, or 0.10. As I just mentioned in the beginning of this video, as we are increasing the value of alpha, we are increasing our tolerance to make type 1 errors. Okay, so now, sorry, I should not say I cannot explain it. I can explain it. So one thing I want to say why type 1 error has to be said this way is that we usually consider the type 1 error causing more harms, okay, causing more harm than type 2 error. If you think about increasing the organic food, the example I just showed you, so the type 1 error actually causing the business losing money, right? So that's really generating more negative consequences than the type 2 error, you just miss a business opportunity, right? So therefore, remember type 1 error, we set up a threshold by ourselves. So if you are really care about making if the type 1 error really cause a lot of harm, you want to reduce your type 1 error to 0.01 or even smaller. If you are thinking type 1 error is very important to be controlled, but the outcome is negative, but it's okay, so therefore you can pick 0.10. But definitely don't pick any value above 0.10. Okay, so when I work in the industry, I do see some analysts chose 0.50, so that means he never take any statistics class. Okay, since you are taking this class from me, just keep in mind the default. We usually pick 0.05 in between, right? And then, but also it's very common to see 0.01 and 0.10. Okay, again, choosing a smaller alpha reflects a greater concern with the consequence of the type 1 error. Okay, so now if I go back to this example about our criminal system, right? So for this type 1 error, what is your pick for alpha? Yes, it has to be small, right? So you really don't want to put an innocent person to the jail or even end up a death penalty. So the type 1 error here, when we are trying to control this type 1 error, we are going to pick a very small alpha value, usually 0.01. Okay. So next video, we're going to move on to look at the decision rule and the critical value.